Hello, my name is Blair Brawley, and I'm a junior from Newport, Tennessee. I'm a biology major with minors in math and physics. And this summer into the fall, I did a research project with Dr. Radfar from the chemistry department. Unfortunately, due to COVID-19, I was unable to return to campus this summer, but luckily I'm able to continue my research this fall. So I'm going to tell you a little bit about our project, and I have some slides to show you along the way. So our project centered around a protein called glucose 6-phosphate dehydrogenase. Our project was to extract and purify and then do enzymatic studies and possibly a crystallization of the protein. Right now, I'm in the early stages. I'm in about the first 1/3 of our project, so I'm still working to extract and purify the protein in the lab. So on the slide, you see a three-dimensional structure of G6PD tetramer that's shown by the green and the purple and the red in these pictures. So why we're interested in this project is G6PD deficiency is the most common enzymopathy in humans. So that just means that there's defective enzymes that do not function properly in the body. There's approximately 400 million people affected by this disease worldwide, and it's much more common in men than women, which is pretty interesting. The disease is caused by a mutation that can be triggered by infection, certain drugs, or food, and patients develop fauvism or a blood disorder. So we're really interested on looking at the structure, the function of the protein, and to do that, I have had to do a lot of extraction, filtration in the lab, and so I have some pictures to show you what I've done so far. So in the early days, the way to get the protein is we extract a portion of the liver, and then we essentially pulverize it with our buffer. And so in the liver, there's so many different proteins in that solution, but I'm only looking for G6PD. So to do that, we have to go through several filtration systems to strain and only keep the protein that I'm looking for. So in the beaker that you see there, that is actually after we had already done 2 filtration methods. First, we used a cheesecloth to get the remaining solids out of the solution, and then we centrifuged at 12 rads per minute for 15 minutes, and the supernatant was saved. We threw away the solid because that's just impurities, and it doesn't have the protein that we're looking for at this time. Next, we still have to try and get the protein isolated because now in the solution, we have so many different proteins, but we're only looking for G6PD. So to do that, we're trying to get it to precipitate using ammonium sulfate, which is just a chemical in the lab that reacts with G6PD. So we have to centrifuge again. Me and this machine got very friendly the first couple weeks of this semester. So as I see on the slide, I added ammonium sulfate to get the protein to precipitate. So in the little test tubes in the pink holder, that is before I put the protein into the centrifuge. So I ran the ammonium sulfate 2 times to get it to the correct saturation. And then at the end, there's going to be a pellet that forms at the bottom of the tube, and that is what's going to actually have my protein in it. And that's what I want to keep and dissolve into my buffer to then use for future studies. All the work that I've done up to this point in the semester, and will continue to do for another 2 or 3 weeks, is to try and get my starting solution for the remainder of the project. I learned a lot of different lab techniques, how to use a centrifuge, how to make solutions, mass quantities of solutions. And so it's been really educational for me and a great experience thus far. So on this slide, you see how the solution no longer looks murky. So that means that the pellet and the protein have separated from the liquid in the tube. So at the bottom, we had success. We have some sort of protein. Now, more than likely, there's going to be more than just G6PD in that pellet at the bottom. But now that I have that, I can dissolve it in my buffer, and I can continue with the rest of the experiment. So this is one of the techniques that I did in the lab. I dissolved my protein sample in the buffer, and then I injected it into a dialyzing cassette that it could be further immersed in the buffer. I had never heard of any of these techniques before, so it was a great learning experience, and this just increases the volume of the buffer and makes sure that it's very homogeneous with the buffer along with the protein. And then later on, I'll be using what's in the center there in the cassette through a column to try and isolate the protein once more. So once the filtration process is finished, then I'll be able to begin enzymatic assays and crystallization structures to try and isolate the protein and learn more about its function and structure. But again, it's been a great experience working on this protein and learning more about the chemistry behind it and how it actually affects the real world due to the G6PD deficiency.